Welcome to LRNGenes videos. Today we're going to be explaining the Trp Operon. An operon is a combination of a set of genes as well as the regulatory sequences that are turned on or off together. Tryptophan is an amino acid that is essential for creating proteins used in cells. It is generally present in the environment, but when it is not, it is regulated by the Trp Operon, which is present in bacteria such as E. coli. There are two ways of regulating the Trp Operon: feedback inhibition and attenuation. However, making tryptophan is very energetically expensive because the operon must transcribe and translate 5 structural genes. If it is present in the environment, the organism will not expend energy to make tryptophan unnecessarily. To make it easier to understand, we're going to relate the Trp Operon to SpongeBob SquarePants. In this analogy, the Krusty Krab is the bacteria that needs Krabby Patties, aka tryptophan, to run. The promoter is the region of mRNA where RNA polymerase III binds to initiate transcription and is shown by Squidward because he interacts with the customers to make Krabby Patties. The operator is the region of mRNA where the repressor binds to inhibit transcription of the structural genes and is shown by SpongeBob because he is the cook of the Krabby Patties. The repressor is the protein that binds to the operator to inhibit expression of the structural genes, which is shown by Mr. Krabs because he tells SpongeBob when to stop making Krabby Patties. TrpR is the gene that's upstream of the operon that codes for the Trp repressor, and is shown by money because this is what tells Mr. Krabs when to shut down the restaurant. If he has money, he doesn't want to keep making Krabby Patties with no customers. TrpL is the leader region of mRNA that encodes for a leader peptide in the attenuator. The attenuator is a uracil-rich region that can interact with a 3 to 4 stem loop to terminate transcription before reaching the structural genes. We will revisit this idea later in the video. TrpE, D, C, B, and A are genes that code for the structural components that make up tryptophan, and they are shown by a bun, patty, lettuce, tomato, cheese, because they are the ingredients that make up a Krabby Patty. RNA polymerase is an enzyme that latches onto the promoter and transcribes the 5 structural genes in the Trp Operon, and is represented by the customers because they bind to Squidward and start the process of transcription or making the Krabby Patties. In this case, tryptophan levels, or Krabby Patties, are high in the environment.
When there's a lot of tryptophan, or Krabby Patties in this case, being made in the Krusty Krab, there is not a need to make any more because this would result in energy being wasted. Before moving any further, it is important to mention that tryptophan, or rather Krabby Patties, act as a co-repressor. A co-repressor is a type of effector which binds to the Trp repressor to create a conformational change, activating and allowing it to bind to the operator and repress the operon. In order to manage these high levels, the Krusty Krab has adopted 2 ways of controlling the production of Krabby Patties: feedback inhibition and attenuation. These methods are essentially used for stopping the production of Krabby Patties and sending customers away. In other words, the operon is turned off. Feedback inhibition involves a repressor that blocks transcription. So in the world of SpongeBob, Mr. Krabs, our repressor, will bind to a Krabby Patty, which will cause Mr. Krabs to change shapes, allowing Mr. Krabs to find SpongeBob, the operator, and stop him from making more Krabby Patties. Once Mr. Krabs is bound to SpongeBob, the customers will be unable to buy any more Krabby Patties, and the operon will be turned off.
In the next example, there's no tryptophan in the environment, so SpongeBob has to make his Krabby Patties.
Bacteria need tryptophan to act as building blocks in protein synthesis. If there is insufficient tryptophan in the environment, the bacteria will have to synthesize it using their own Trp Operon. This is just like the Krusty Krab being out of Krabby Patties. It will have to make some from scratch. In the absence of the co-repressor, tryptophan, the repressor will not have the correct conformational shape to bind to the operator and inhibit transcription. RNA polymerase will therefore be able to pass the operator without obstruction and transcribe the Trp Operon to synthesize tryptophan. When the Krusty Krab is out of Krabby Patties, SpongeBob will have to make some from scratch. Mr. Krabs will not have any reason to tell SpongeBob to stop making patties, therefore the customers will be able to order patties that SpongeBob will create on the spot.
We will first describe the mechanism of attenuation before explaining it in terms of SpongeBob. Attenuation occurs after the initiation of transcription, but before transcription of the operon is completed. Feedback inhibition, the primary means of regulation, is more like an on-off switch, while attenuation is a fine-tuning dimmer switch. The gene that initiates this process is TrpL, a regulatory element between the operator and the structural genes. This gene is considered the leader sequence and contains 2 tryptophan codons. There are 4 regions in the leader sequence, and they are highly complementary. These base pair interactions in this region result in the single-stranded mRNA folding over and binding, where results are hairpin stem loop structures in the RNA transcript. Region 2 is complementary to regions 1 and 3 and can form a stem loop with either, but not both at the same time. Region 3 is complementary to 2 and 4 in a similar manner. The attenuator follows region 4. If the 3-4 stem loop is present, it acts with the attenuator to form a terminator at the end of the gene, stopping transcription of the structural genes. If the 2-3 stem loop is present, then the terminator structure does not form and transcription proceeds. So if tryptophan levels are low, then tryptophan tRNA levels are subsequently low. The ribosome has to pause at region 1 to wait for the trip codon to add tryptophan to the growing protein. Region 1 is then physically blocked from forming a loop with region 2, thus freeing region 2 to form a stem loop with region 3. Since the 3-4 stem loop did not form, the RNA polymerase continues to transcribe the biosynthesis genes. If tryptophan levels are high, the ribosome will not be stalled at region 1 because tryptophan codons are present. So, translation will continue until a stop codon for the TRPL gene is reached, where it experiences the normal pause that occurs during termination of translation. While paused at this stop codon, the ribosome physically blocks region 2 from interacting with region 3. Therefore, a 3-4 stem loop readily forms, leading to termination of transcription before the structural genes are reached. The result is that the trp operon is turned off by attenuation when tryptophan levels are high. You can think of attenuation, this secondary or backup form of regulation, as the backup vault in the Krusty Krab. Attenuation will only occur if there are low levels of tryptophan, or Krabby Patties. However, if the vault contains Krabby Patties, then there's no need for SpongeBob to make any, and Mr. Krabs will prevent this from occurring. On the other hand, if no Krabby Patties are present in the vault, SpongeBob will have to make them to meet demand.
Thanks for watching the LRNGenes Trp Operon video.